Imagine waking up tomorrow. The beaches are gone. Miami gone. Large parts of New York, underwater. Entire countries, disappearing beneath the ocean. Now here's the crazy part. 100 feet of sea level rise isn't even Earth's worst-case scenario. If every glacier and ice sheet on Earth melted, sea levels wouldn't rise 100 feet. They'd rise more than 200 feet. But today we're stopping halfway, because even 100 feet would completely redraw the map of our planet. Cities would disappear, millions would be forced to move, the internet itself would begin to fail, and civilization would have to adapt to an Earth that hasn't existed for thousands of years. So, what would actually happen? First, let's clear up one huge misconception. This isn't some random number people pulled out of thin air. 100 feet sounds impossible, but it actually comes from real geology. If Greenland's massive ice melted completely, sea levels would rise about 23 feet. Now combine that with the collapse of large parts of West Antarctica, and suddenly, you're approaching the 100-foot mark. That's still nowhere near all the ice on Earth. If Antarctica melted entirely, sea levels would rise nearly 190 feet by itself. Add every glacier and ice sheet across the planet, and you're looking at around 216 feet of sea level rise, which means 100 feet isn't the maximum. It's the middle of the nightmare. But here's something even stranger. Earth has actually experienced changes like this before. Around 20,000 years ago, during the last ice age, sea levels were almost 400 feet lower than they are today. Back then, so much water was trapped inside enormous ice sheets that people could literally walk across land that's underwater today. We're not talking about a planet doing something it's never done before. We're talking about reversing a process that's happened many times throughout Earth's history. The difference is, this time, there are 8 billion people living on those coastlines. When most people imagine rising sea levels, they picture a giant tsunami, massive waves crashing through cities, people running for their lives. Hollywood loves that image. Reality is actually much scarier. The ocean doesn't arrive all at once. It creeps, year after year, inch by inch, almost too slowly to notice, until one day, you realize the place you've lived your entire life simply isn't livable anymore. It's like watching the minute hand on a clock. You never actually see it move, but somehow, hours have passed, and once the water reaches your city, it doesn't stop at the shoreline, because that's where the real problems begin. Here's something almost nobody talks about. The first thing the ocean floods isn't your house, it's the ground underneath it. As sea levels rise, the groundwater beneath cities rises too. That means places miles away from the coast can begin flooding before the ocean ever reaches them. Storm drains stop working, basements start filling with water, roads begin cracking, sewer systems back up, and suddenly, cities are dealing with floods without ever seeing a wave. Even worse, salt water starts pushing into underground freshwater supplies. The wells communities depend on become contaminated. Drinking water becomes harder to find. Farms struggle to irrigate crops. And this happens long before satellite images show cities underwater. The disaster starts underground, where almost nobody can see it. But underground pipes aren't the only thing hiding beneath our feet. Because buried underground is something civilization depends on every single day. The internet. Most people imagine the internet floating around in satellites. It doesn't. The vast majority of it runs through physical cables, thousands of miles of fiber optics, buried beneath roads, running under sidewalks, connecting massive data centers together. And here's the problem. Many of those systems were built just a few feet above today's sea level. Cities like New York, Miami, and Seattle are some of the most vulnerable. Once seawater reaches those cables, it doesn't simply get them wet. Salt water slowly corrodes the connectors, damages networking equipment, and keeps destroying infrastructure, even after the floodwaters disappear. But that's not even the weakest part of the internet, because the places where continents connect to each other are sitting exactly where you would expect them to be, right on the coast. Those tiny buildings along the shoreline connect entire continents together, and if they fail, the effects wouldn't stop at buffering videos or slower downloads, because right next to many of them are something far more dangerous than internet cables: nuclear power plants. And what happens next could change civilization forever. If internet cables fail, life becomes inconvenient. But if critical infrastructure fails, life becomes dangerous. Here's something most people don't realize. Many nuclear power plants were built right on the coast. Not because it's convenient, but because reactors need enormous amounts of water to stay cool. The ocean is basically a giant cooling system. It's brilliant, until the ocean starts moving inland. In the United States alone, more than 100 nuclear reactors are located near coastlines or large bodies of water. Now, this doesn't mean rising seas automatically cause nuclear disasters. Modern plants have multiple layers of protection and are designed with extreme events in mind. But flooding still creates serious challenges. Roads become inaccessible. Backup systems can be disrupted. Cooling infrastructure becomes harder to protect, and surrounding communities may have to deal with prolonged emergencies. But nuclear plants aren't even the biggest environmental threat, because they're surrounded by thousands of chemical plants, fuel depots, oil terminals, sewage treatment facilities, and industrial storage sites. Imagine millions of gallons of chemicals being released into floodwater. Now you're not just fighting the ocean, you're fighting contamination. But losing a few cities isn't what changes the world. It's what happens after everyone leaves. Where do millions of people go when home no longer exists? That's a question scientists are already trying to answer. And surprisingly, some cities may actually benefit. Places like Buffalo and Duluth are already being called potential climate havens. They're far from rising oceans. They sit beside enormous freshwater lakes, and they generally experience cooler temperatures than many coastal regions. As more people move inland, these cities could grow dramatically, but growth isn't always good. More people means higher rent, more traffic, more competition for housing. Schools become crowded, infrastructure gets stretched, and people who've lived there for decades could suddenly find their hometown too expensive to afford. Ironically, the safest places become the hardest places to live. But while people are moving inland, the map itself is changing. Florida almost disappears. Not just Miami, not just Tampa, large parts of the entire state. Because Florida isn't just surrounded by water, it's barely above it. Now look west. California doesn't simply lose beaches. Its geography changes. The Central Valley, one of the most productive farming regions in America, could transform into a massive inland bay. Even San Francisco changes dramatically. Its famous hills could become islands. And New York? New York is one of the best examples of why sea level rise isn't linear. At 6 feet, it's a serious problem. At 100 feet, it's an entirely different world. Large portions of the city, and nearly all of Long Island, disappear beneath the ocean. It's not a slow increase in damage. It's a tipping point. One extra foot doesn't always mean one extra foot of flooding. Sometimes, it means an entirely different coastline. And then, something even stranger happens. The ocean starts uncovering the past. Long before modern cities existed, people lived on land that's already underwater today. One of the most famous examples is Doggerland. Thousands of years ago, Britain wasn't an island. It was connected to mainland Europe by a huge stretch of land filled with forests, animals, and human settlements. Today, it's buried beneath the North Sea. Fishermen still occasionally pull up. Stone tools, ancient bones, even mammoth remains. The same thing happened across Southeast Asia, where enormous areas known as the Sunda Shelf were once dry land. If the oceans rose another 100 feet, we wouldn't just lose cities. We'd begin covering today's civilization, just like the civilizations before us. Thousands of years from now, someone else could be exploring our skyscrapers, the same way we explore ancient ruins today. Now, here's the good news. This isn't a prediction. Scientists are not saying the oceans will rise 100 feet by the year 2100. In fact, current mainstream projections for this century are much lower, and melting enough ice to raise the oceans by 100 feet would likely take centuries, possibly even thousands of years. So why imagine it at all? Because what if scenarios reveal something important? They show us where civilization is vulnerable. They remind us that coastlines, maps, and even countries aren't permanent. Earth has changed before. It will change again. The only question is whether humanity changes with it or gets left behind. The world we know today exists because the oceans stopped rising thousands of years ago. If they ever started climbing again, the biggest change wouldn't be the water. It would be us.